Hey guys, in the last video I showed you an 8-position drum type tool changer that I was working on for an individual who was retrofitting a older vertical machining center. It was a Brother TC201, one that he had gotten from a high school or trade school, and so he was looking to use Mach 3 to operate the drum tool changer. Well, that got me intrigued and interested in the whole drum type changer altogether. And so I started working on the screen set that you see in front of you, which is a 16 tool plus one in the spindle drum type arm tool changer. So let's kind of go over it. It is a little bit different than the last video. I removed the X and the Y axis from the ATC tab. Those aren't really needed, I didn't think, for this particular tab. Really the only three axes you'll be using for this macro are the Z to move the head up, B axis to rotate the drum, and the C axis to actuate and rotate the arm. So those are the three listed. Again, we have our touch off tool offset box here. We have our power drawbar button, which I didn't use in the last video because he had an Arduino that it was going to handle the arm and the power drawbar, so I didn't include that in his screen. And I've changed the graphics a little bit. The drum graphic, we now have a down and up for the pivot, the actual tool holder that pivots down, and up. And of course the drum, I've changed it a little bit and we now have 16 positions. And so I've been working on the macros for this, so let's kind of go over it and let me show you what I've got. Now I've went ahead and loaded all the tools up to tool number 14, and I left tool 15 and 16 position open so that I could show you how the load tool button actually works. So you have 16 tool positions, and sometimes you may overlook that you already have a specific tool number used. You may have done some changes to your tool table. So let's say you try to load tool number 14, which already happens to be in the drum, or at least Mach 3 thinks it's in the drum. So let's see what happens. So we're going to hit load tool. The tool's actually already inserted into the spindle, and we're just going to hit load tool. Now to do that, you simply push the power drawbar button. For 3 seconds, the drawbar will release so that you can insert tool number 14. Again, push the button, 3 seconds, which give you plenty of time to insert a tool. As you can see, the power drawbar button LED turns green to let you know that it is released. Once you have tool 14 into the spindle, you can push the load tool button. A message pops up and lets you know that tool number 14, and gives you a description of the tool, is already in use. And so we look at our drum and we see that tool 14 is in fact already in use. It also gives us a message down here in the status bar. So let's change that to tool number 15. And now let's try to load tool number 15. Now it says please insert tool number 15 And again, it gives you a description of the tool so that you can verify that that is in fact the tool that you are loading. We're going to click OK. Now when we do click OK, there's a few things that are going to happen. We're going to rotate to the next available position, which happens to be position 15. So you'll see the B-axis move. We're also going to lower that slot, so you'll see the pivot come down. Now I'm going to have to simulate the inputs to make sure that the pivot is down, so we may get this messed up, but we'll see how it goes. Once the pivot's down, the arm will move. You'll see this flash. You'll see the C-axis rotate to 90 degrees. Pick up the tool, and then the arm will go down with a pneumatic cylinder. Rotate to 270 so that it swaps the positions. The pneumatic cylinder will de-energize. Lift the tools up. Insert the new tool 15 into the drum, and it won't insert anything, tool 0, because there's nothing there, into the spindle. So we'll have an empty spindle. Then you'll see C-axis rotate back to 0, and you'll get an input here showing that the arm is clear. So let's see if we can make all this happen. Because I'm just simulating this, I'm having to hit the keys to simulate the inputs, but hopefully I can get it right. So we're going to click OK. We're going to see our B-axis rotate to the correct slot, which is 15. We're also showing that 15 is where we're going to be going. Our arm is made, and now that when we retract, okay, we see that tool 15 is loaded into slot 15 and 0 is back in the spindle. That all happens kind of fast, but hopefully I'll do it again and we can see these inputs here. But we have our input showing that the pivot is down. We have our input showing that the pivot is retracted, and we have our arm which turns green to let us know that it's clear. Alright, so now let's try to load tool 16. We'll do it again so you can see everything as it happens. Again, when the pivot extends, you'll see a red input letting you know that it is extended, green for retracted, and when the arm is clear, you'll get a green input letting you know that the arm is clear. So let's do it again, and hopefully you can see what's happening. It happens real fast, so it's kind of hard to see, but let's give it a shot. So we're going to load tool. We're going to insert tool 16. We're going to check the tool description, verify that it's correct, and then click OK. C rotates, power drawbar goes down, the arm clears, and we retract, and tool 16 is loaded into the drum, and tool 0 is in the spindle. Now, if you want to manually rotate your drum to any one of the positions, just simply hit the button here, or the number for that slot, and we will rotate to that slot. Slot 1 being 0, slot 2 being 22.5, 16 being 337.5. Notice that we rotate in the shortest distance. So we're on 16. Let's see which direction it goes to get to 9. So you can see that it's going this direction because that was the shortest distance. So if you'd like to manually rotate the drum, you can do so. to check tools. Then you can also push these buttons here to pivot this slot 9 down. And when you do that, you'll get your input showing you that it's down. This is if you would like to verify tools that's actually indicated in the DRO that's physically into the drum. You can use this method. With the load tool macro, if one of the actions does not happen in time, if the pivot does not come down, you will get a error message. So let's simulate that. I'm going to do tool 16 again. So we'll load tool. It's going to ask us to insert that tool, and we're going to click OK. Actually should change that message to ask if that tool is actually inserted. You should probably insert that tool before you start the load tool button. Okay, we're rotating over to position 16. After the rotation of the drum, we get an output to lower the pivot. If the pivot does not reach the lower position in a designated amount of time, then you will get this error message showing that the pivot there's a jam, it didn't lower. Likewise, you get the similar message if it does not retract. And if there is a problem with the arm, you'll also get a message. So let's try that with the arm. Again, we get our message. The pivot lowers this time. The arm does its change, but after the tool change, the arm did not rotate back to the clear position. So you'll get this message here. And notice we didn't get our clear input here. If in fact it does clear, then you can hit retry. You'll get your input there, and then it will retract the pivot. If the pivot does not retract in time, again you'll get a pivot retraction failed message. So there's a lot going on there. You never really see it when it's working, but there are inputs that need to be made in order for the tool change to complete. After the tool is installed, then you will get a status down here letting you know that we did in fact install tool number 16 and give a description of the tool. Now this information is pulled from your tool table. So whatever you have in your tool table for tool 16, you can see that's the information that we have. 3/8 inch 4-flute ball nose. And so that's exactly what it tells us down here. Okay, so I've got the drum loaded with some tools, and notice that each of the tools actually corresponds with the slot number. So what we're going to do now is I'm going to just run this G code, which is just a bunch of tool changes, and we're just going to make in a circle. So let's run the code, and you can actually see how this thing is working. So we're going to hit cycle start. We're going to go get our full tool, which happens to be tool number 5. It gives you the information down here, which tool we're going to retrieve. So I'm going to try to hit all these inputs at the right time and hopefully get a good tool change. Didn't clear the arm. Okay. Alright, so the tool change completed. Is that correct? And then now we are moving. We're actually doing this program here. The next tool is tool number 4. So it gives you the information down here which tool we're going to be getting first. Next is tool 4. Okay. Pivot extended, arm. We do a rotation, we retract, and we go start running our code again. Now, of course, this macro may have to be tweaked somewhat for a particular machine that you may be wanting to use it on. You may want to use an Arduino to handle some of the function, but I've got it set up now where Mach 3 will actually handle all of these functions. We're getting tool 7 here. There goes the arm. Power drawbar releases, arm clears, we retract, and we go on to the next tool change. Notice our spindle updates, and if you notice now that our first tool change was, we went and got tool number 5, and we had tool 0 in the spindle, so it replaced tool 5 with 0. So now this slot is actually empty. Going to get our next tool. Pivot extended. Arm. And we retract. Okay. And you can see that the drum is dynamically updating here. So we used tool 5 first, and then the second tool was tool 4. So we went and got tool 4 out of slot 4, and we replaced it with tool number 5. Our next tool number was 7. We've replaced 4 with 7. Our next tool here is tool 10, which is in slot 10, so we should replace tool 10 with tool 8. Here we go. Alright, I can't hit the buttons fast enough, sorry, to get a clean tool change here. So we've replaced tool slot 10 with tool number 8, and 10 went into the spindle. So you can see how the drum dynamically updates. Our next tool number will be 11, so we'll replace 11 with 10, and 11 will go into the spindle. Also, you get an indication here of which tool you're actually using. Tool change. Alright. So in slot 11, tool 10 went, and tool 11 went into the spindle. Again, the tool number here is the tool we're using. It gives you the offset information, the diameter information, whatever's stored in your tool table. I think there's a couple of more tool changes here, but I don't think we need to go through those. I think you guys kind of got the understanding of the way the screen set and macro works. So what we have is a 16+1 screen set. We retrieve the tool and store the tool in the same location. We're dynamically keeping track of all the tools in the drum. We're running 2 motors, our B axis for our drum, our C axis for the arm. We have 3 outputs. We have 1 output for the pivot up and down. When it's energized, the pivot goes down. When de-energized, it comes back up and returns. We have 1 output for the power drawbar. to release the tool, and we also have one output for a pneumatic cylinder to lower the arm. We have 4 inputs configured: our B-axis home, our C-axis home location, our pivot up, and our pivot down. So that's pretty much it. If anyone's interested in a screen set and macro to retrofit an older VMC, please let me know. Stop by and visit the website at www.cncforxr7.com. If you have any suggestions or questions, please feel free to comment. Thanks for watching. Please subscribe, thumbs up if you liked the video, and most importantly, be safe.